All right, so let's look at another example here. Now, all three of these examples that we've demonstrated in here have started with the choosing a single um, individual or manhole or woman or cord, or and then the second example is always choosing a sample and asking a question about the sample average. I will say that most of the time we're going to be doing the second part. We're going to be finding probabilities of a sample mean being in a certain range without doing the first part. Right now we're just doing these first parts so that we can get used to the difference and get used to recognizing the difference. So in this one we've got quarters that are normally distributed. Their weights have an average of 5.67. So they have an average of 5.670 with a standard deviation of 0.062. And so we've got a vending machine that is configured to only accept quarters between 5.55 and 5.790, right? Because if it's too high or too low, it's probably a fake quarter. So the first question is, if you choose one at random, what's the probability that it will be accepted? In other words, what's the probability that it will be between the low range, 5.550, and the high range, 5.790? Okay, so we want to find that area in between those two boundaries. So we're just taking one quarter at a time, so we know what to do here. We just find the z-score of each boundary, so let's find the z of the right boundary, the 5.79, right? 5.790 minus 5.670 over the standard deviation, right? Just like we've always done it. So we're going to find that area, or that z-score. So this is the z-score, 1.94. I'm going to put that in blue, 1.94. Okay, so remember, to find areas in between two, you go ahead and find the area to the left of the right boundary. So that's what we're going to do. We're going to look up 1.94 in our table right now, and we'll get 0.9738. Okay, so that's the area from here on to the left, 0.9738. And then we do the same for the left boundary. Find its z-score, 5.55 minus 5.79 over, or sorry, not 5.79. Need the mean there. 5.67 over 0.062. And so we want that 5.55 minus 5.67 divided by 0.062. And that z-score is negative 1.94. All right. And so we look up negative 1.94 in our table, negative 1.94, and we get 0.0262. So the area from here to here is 0.0262. So the area between them will be the 0.9738 minus 0.0262. So the area is 0.9476. So there is a 94.76% chance that this single quarter will be accepted. All right. Moving to part 2 says, okay, what if we choose four random ones, and what's the probability that the average of those four is between these same two boundaries? So we have, now this is the distribution of sample means, so we need the mean of the means, because this is a question about the probabilities of means. So the mean of the means is still 5.670. The standard deviation of the means, or or standard error, is sigma over square root of n, which is 0.062 over square root of 4, right? 0.062 divided by 2 is 0.031. Our boundaries are the same, 5.55 and 5.790. So we're going to do the same thing. We still want to find the area in between those two. So we find the boundary of the right, which is 5.79 minus 5.67. But now we use the standard errors, which is 0.031. Okay, 5.79 minus 5.67 divided by 0.031. And so we get 3.87. That's pretty high. We know the area to the left of it, certainly not indicative by this picture, but the area to the left of it is 0.9999. Okay. So now we find the area, or the z-score of the left, 5.55 minus 5.67 over 0.031. Okay. And that's a negative 3.87. Okay, and so the area to the left of that, again looking in our table, from there is 0.0001, or actually probably 0 plus. But if I do 0.9999 minus 0.0001, I get 0.9998. So there's a 99.98% chance that the average of 4 quarters will fall in that range. Okay? All right, so the third question. If you own the vending machine, which result is more important, the result from 1 or 2? And my belief is the result is 1 is more important, because you want to you're worried about individual quarters in that machine, right? Every quarter is weighed on its own merits. You want to accept a quarter or not accept a quarter, all right? You don't want to accept 4 quarters based on their average being in a certain range. You want to judge every single individual quarter. So part 1 is more important. And part 1 says that if we establish these 2 weight limits, 550 and 579, then we will be accepting about 94.76% of the quarters, right? But there's a little over 5% that we won't accept because they were overweight or underweight.